Have you ever stood in the quiet stillness of a dark room, long after the rest of the world has fallen asleep, and wondered where the boundaries of your reality truly begin and end? Have you ever looked out of a window into the pitch-black night, straining your eyes to see beyond the shadows, feeling an instinctual curiosity about what lies hidden in the unseen depths? It is a profoundly human experience to search for the edge of things. We are creatures of boundaries, accustomed to maps with defined borders, to oceans that meet the shore, to the comforting geometry of walls and ceilings. When we look up at the night sky from our small rocky planet, we are often comforted by the illusion of a celestial dome, a fixed canopy of stars that seems to wrap around our world like a protective blanket. But the cosmos does not offer us a ceiling. It offers us a profound, endless depth, an open invitation to a journey into a silence so absolute that it challenges everything we think we know about our place in the grand architecture of existence. Before we step further into this vast mystery and leave the familiar shores of Earth behind, allow me to introduce myself. Hello, I am Theodore, the researcher, your gentle guide on this quiet journey through the wonders of the cosmos. I have noticed that 71% of the kind souls who watch and listen to these cosmic explorations have not yet subscribed to the channel. If you find peace, comfort, and wonder in these stories, please consider subscribing. It helps our small community grow immensely and allows us to continue exploring the infinite together, providing a sanctuary of knowledge and calm in a busy world. Let us return to the dark, peaceful ocean of the night sky. For generations, humanity has peered through the lenses of increasingly powerful telescopes, hoping to find the edge of the universe. We sought a boundary, a place where the stars simply stop, where the fabric of space comes to a neat and comprehensible conclusion. Instead, we found a reality that defies our most basic intuitions. We discovered that our universe is expanding, stretching outward in all directions, carrying galaxies away from each other in a gentle, relentless swell. And recently, our ability to see into this expanding dark has taken a monumental leap forward. The James Webb Space Telescope, a marvel of human engineering and a testament to our insatiable curiosity, now floats in the freezing void of space, positioned about 1 million miles from Earth. This magnificent observatory is not merely a camera, it is a time machine designed to capture the ancient, invisible light of the deep cosmos. Imagine the journey of this remarkable instrument. It was folded perfectly into the fairing of a rocket, launched into the heavens. And then, in the absolute quiet of deep space, it began to unfold like a delicate golden flower. Its primary mirror, made of 18 hexagonal segments coated in a microscopically thin layer of real gold, measures over 21 feet across. To function properly, this telescope must be kept incredibly cold, operating at temperatures near minus 390 degrees Fahrenheit. In this profound cold, enveloped by the silence of the void, the James Webb Space Telescope turns its golden eye toward the darkest patches of the sky, gathering photons that have been traveling for over 13 billion years. It is collecting the whispers of the primordial universe, offering us a glimpse of the cosmos as it was shortly after the dawn of time itself. To look deep into space is to look deep into time. Because light travels at a finite speed, it takes time for the image of a distant object to reach our eyes. When you look at the moon, you are seeing it as it was about 1.3 seconds ago. When you look at the sun, you see it as it was 8 minutes ago. But when the James Webb Space Telescope looks at a distant galaxy, It is capturing light that began its gentle journey before our sun was even born, before our planet was a swirling cloud of dust. A single photon of infrared light, born in the fiery heart of a primordial star, travels across the expanding void, bypassing turbulent galaxies and dark nebulas, coasting through the silent vacuum for billions of years, only to finally, quietly, strike a golden mirror built by curious minds on a small blue world. And yet, as this incredible instrument peers further back in time and further out into space than we have ever managed before, it is finding things that deeply challenge our understanding. The telescope has observed fully formed, massive galaxies existing in an era where our current models suggest they should not yet have had the time to grow so large. It is seeing structures that are too mature and too vast for the young universe they inhabit. This brings us to a profound scientific paradox, one that forces us to reconsider the very nature of the cosmos. Are we misunderstanding the early history of our universe? Or is there a fundamental flaw in how we perceive the entire structure of reality? To answer this, we must first understand the concept of the observable universe. The observable universe is essentially a sphere of light centered on the observer, which is us, here on Earth. Because the universe is about 13,800,000,000 years old, and because space itself is expanding, the current diameter of this observable sphere is roughly 93 billion light-years across. That is a distance so vast that the human brain cannot truly comprehend it. We can only map it mathematically and admire it philosophically. Everything we can see, every star, every galaxy, every wisp of cosmic dust lies within this sphere. But what lies beyond it? For a long time, the standard cosmological assumption was simply more of the same. An infinite expanse of galaxies stretching out forever, looking roughly identical to our own local cosmic neighborhood. This edge, the boundary of the observable universe, is not a physical wall. It is a horizon of time and light. Beyond that horizon, there are undoubtedly more galaxies waiting in the dark. We simply cannot see them because their light has not yet had enough time to cross the expanding gulf of space. However, recent observations of the cosmic microwave background, which is the fading afterglow of the Big Bang itself, combined with the movements of massive galaxy clusters, have started to reveal a tantalizing possibility. We are beginning to detect the gravitational influence of things that exist beyond our observable horizon. It is as if we are sitting in a boat on a fog-covered ocean, unable to see the distant shore, but feeling the undeniable pull of a massive, unseen current beneath the water. Astronomers have given a name to one of these mysterious phenomena. They call it the dark flow. Scientists have observed massive clusters of galaxies moving together in a specific direction across the universe. They are streaming toward a particular patch of sky at speeds of millions of miles per hour. This movement cannot be fully explained by the gravitational pull of the matter we can see within the observable universe. If the universe extended infinitely, with the same density of matter everywhere, these clusters should be pulled equally in all directions. But they are moving. They are being pulled by an immense gravitational force originating from something massive that lies hidden entirely outside the boundaries of our observable reality. This anomaly suggests a reality that is almost too vast to hold in the mind. It implies that the universe as we know it, with its 93 billion light-years, its 2 trillion galaxies and its countless trillions of stars, might just be a small, localized region within a much larger superstructure. Are we floating inside a grander structure? Could our observable universe be nothing more than a tiny bubble within a vast cosmic foam? These questions push the limits of human knowledge and blur the line between astrophysics and philosophy. They force us to confront our limitations, but they highlight the exquisite beauty of our curiosity. We are made of the same ancient star stuff that fills these distant galaxies. Yet, we have awakened and begun to map the infinite. This thought should fill us with awe and a deep, comforting peace. To know that we are part of a mystery so grand, to feel the gentle pull of the unknown without needing to conquer it, is to find a quiet harmony with the cosmos. We are an active, conscious part of its boundless exploration. As we prepare to delve deeper into the data the James Webb Space Telescope sends back to us, I invite you to rest in the comfort of this vast mystery. Let the silence of the cosmos wrap around you. Let the ancient light of distant stars remind you that time is long, space is wide, and the universe is far more magnificent than we ever dared to dream. The journey of discovery is infinite, and we are just taking our very first steps into a reality that is larger, stranger, and more beautiful than our wildest imaginations. Imagine stepping into a quiet, shadowed nursery, expecting to find fragile, newborn infants, but instead finding fully grown adults, standing tall and complex, holding the quiet wisdom of a lifetime. This jarring sense of displacement, this profound contradiction of expectations, is precisely what astronomers felt when the first deep-field images from the James Webb Space Telescope were downloaded to Earth. We had built this magnificent golden mirror specifically to peer into the cosmic dawn, to witness the very first fragile sparks of starlight emerging from the primordial darkness. Our current, carefully constructed models of cosmic evolution told us exactly what we should see. We expected to find tiny, chaotic clumps of gas and newborn stars, the messy, unstructured building blocks of what would eventually, over billions of years, merge and grow into the majestic spiral and elliptical galaxies we see in our local universe today. We expected to see the universe in its infancy, taking its very first hesitant steps into the light, but the universe, in its infinite wisdom and silent grandeur, presented us with a mystery that fundamentally challenges our understanding of how everything began. As we navigate this profound contradiction, allow me to remind you that I am Theodore, the researcher, your companion on this quiet journey through the mysteries of the night. I have observed that 71% of the curious souls who find solace in these cosmic tales have not yet subscribed to our channel. If this gentle exploration of the vast unknown brings you peace and wonder, please consider subscribing. It helps us continue to craft these stories and ensures that our shared journey into the infinite cosmos can carry on, providing a calm refuge for wandering minds. Now, let us return to the golden eye, floating in the deep freeze of space. To understand why these findings are so revolutionary, we must gently unpack how the James Webb Space Telescope actually sees the universe. Light, as it travels through the expanding fabric of space, gets stretched. Imagine a tightly coiled spring being slowly pulled apart. The distance between each coil becomes longer. In the cosmos, as space itself expands, the light waves traveling through it are stretched out, their wavelengths becoming longer and longer. By the time the light from the very first galaxies reaches us, after traveling for over 13 billion years, it has been stretched so far that it is no longer visible to human eyes. It has shifted out of the visible spectrum and into the infrared. This is a phenomenon astronomers call redshift. The James Webb Space Telescope was engineered with breathtaking precision to detect this faint, ancient infrared glow. It is essentially a heat-seeking instrument, which is why it must be kept at temperatures of minus 390 degrees Fahrenheit, shielded from the sun by an enormous protective barrier. If the telescope were even slightly warmer, its own thermal radiation would blind it to the delicate whispers of the distant universe. Working in perfect silence, a million miles away from the warm glow of our planet, it captures photons that have been on a quiet journey since the universe was just a few 100 million years old. And what did these ancient photons reveal? They painted a picture of a past that seemed mathematically impossible. Deep within the data, scientists identified a population of extraordinarily massive galaxies existing just 500 million to 700 million years after the Big Bang. According to our standard cosmological model, a timeline painstakingly pieced together over decades of rigorous observation and theoretical physics, there simply was not enough time for galaxies of this colossal size to form. These structures contain tens of billions of solar masses worth of stars. They are as mature and densely packed as our own Milky Way. Yet they are sitting in an era when the universe was merely 3% of its current age. It is as if the cosmic clock was somehow ticking faster, or as if the seeds of these galaxies were planted long before the universe itself supposedly began. The sheer mass of these ancient structures creates a profound tension between what we observe and what we believe to be true. It invites us to ask a humbling question. Are we merely missing a chapter in the story of galaxy formation, or are we misunderstanding the entire book? This tension is not a failure of science. Rather, it is the beautiful, quiet heartbeat of discovery. Every time the cosmos defies our expectations, it offers us a gentle invitation to expand our minds, to shed our preconceptions, and to embrace a grander, more complex reality. To find clues that might resolve this paradox, astronomers must look not just at the galaxies themselves, but at the empty space between them and even further back, to the oldest light in existence. Long before the first stars ignited, the universe was a dense, glowing fog of plasma. As the universe expanded, it cooled. About 380,000 years after the Big Bang, the temperature dropped just enough for the first atoms to form. The dense fog finally cleared, and light was able to travel freely through space for the very first time. That first burst of light is still traveling today, wrapping around us from every direction in the night sky. We call it the cosmic microwave background radiation. It is the afterglow of creation, the fading echo of the Big Bang itself. By mapping tiny, almost imperceptible temperature fluctuations in this background radiation, scientists can read the genetic code of the early universe. These microscopic variations in temperature, differences of just a few millionths of a degree, represent the initial seeds of matter, the slightly denser regions that would eventually collapse under the gentle pull of gravity to form the vast cosmic web of galaxy clusters we see today. But even this ancient map holds mysteries that point to a larger, unseen reality. When we examine the cosmic microwave background with instruments of extreme precision, such as the Planck satellite, we find anomalies that our standard models cannot easily explain. One of the most fascinating is known as the cold spot. This is an unusually large region of the sky where the temperature of the background radiation is significantly cooler than the surrounding areas. It is far larger and colder than statistical models predict should be possible in a completely uniform, isolated universe. Some scientists have proposed that this vast cold void could be an optical illusion caused by an enormous supervoid in the foreground of the cosmos, a region virtually empty of galaxies that subtly drains energy from the light passing through it. But others have suggested a far more poetic and mind-bending possibility. What if the cold spot is a cosmic bruise? What if it is the lingering scar of a collision between realities? In the framework of multiverse theories, our universe might not be the only bubble of space expanding in the vast, infinite bulk of a higher dimensional void. If another universe, expanding in the same metaspace, bumped into ours in the very distant past, it could have left a thermodynamic imprint on the cosmic microwave background, a quiet signature of a reality that exists completely outside our own. The legendary astronomer Carl Sagan once elegantly reminded us that the cosmos is all that is, or ever was, or ever will be. But perhaps, as we gaze at these new anomalies, his beautiful definition of the cosmos must extend far beyond the observable bubble we call home. We find ourselves standing on the shores of a vast cosmic ocean, peering into a thick mist that conceals wonders far beyond our wildest imagination. The massive galaxies that should not exist, the mysterious dark flow pulling entire clusters toward an unseen destiny, and the cold scars delicately etched into the primordial light, all quietly whisper the same tantalizing secret. The universe we can see, as vast and ancient as it is, might only be a single, quiet room in an infinitely larger mansion. It is a profoundly humbling realization, one that gently dissolves our human sense of centrality and replaces it with a profound, respectful wonder. The cosmos does not owe us simple answers. It exists in a continuous state of majestic complexity, inviting us to look deeper, to question harder, and to rest comfortably in the knowledge that some mysteries are so grand they may take 1,000 lifetimes to unravel. As we continue to gently drift through this endless sea of ancient stars, let us embrace the silence, the mystery, and the beautiful uncertainty of it all. The journey is far from over. Have you ever floated on your back in a calm, quiet lake, closing your eyes and surrendering completely to the gentle rhythm of the water? If you stay perfectly still, you might begin to notice that you're not actually stationary. A subtle, invisible current, perhaps born from a distant wind or a hidden spring deep beneath the surface, is slowly carrying you away from where you started. You cannot see the current, nor can you hear it, but you can undeniably feel its persistent, silent pull guiding you through the water. This profound sensation of invisible motion is not merely a terrestrial experience. It is the fundamental reality of our existence in the cosmos. When you stand in your garden and look up at the ancient, infinite canopy of the night sky, you might feel anchored to the solid earth, secure in the quiet stillness of the dark. But this stillness is a magnificent illusion. Our entire world, our sun, and our entire galaxy are adrift in a vast, invisible cosmic ocean, being pulled by forces so immense that they stagger the human imagination. Before we surrender to this cosmic current and journey further into the profound mystery of our moving universe, allow me to warmly welcome you once again. I am Theodore, the researcher, your gentle companion on this quiet journey through the wonders of the dark. I have gently noticed that 71% of the beautiful minds who join us for these starlit contemplations have not yet subscribed to our channel. If you find comfort, wonder, and a sense of peaceful belonging in these stories, please consider subscribing. Your presence helps our quiet community flourish, allowing us to continue our shared journey into the infinite together, building a sanctuary of curiosity and calm. Now, let us return to the silent, rushing waters of deep space. To understand the grand architecture of the universe, we must first abandon the comforting idea that anything is ever truly at rest. Our Earth is spinning gently on its axis at roughly 1,000 miles per hour at the equator. It orbits our Sun at 67,000 miles per hour. Our entire solar system is gracefully completing a massive lap around the center of the Milky Way galaxy at a breathtaking speed of about 500,000 miles per hour. But the motion does not stop there. The Milky Way, along with our neighboring Andromeda galaxy and dozens of smaller dwarf galaxies, forms a quiet neighborhood known as the local group. And this entire neighborhood is plunging through the universe at an astonishing velocity of roughly 1,300,000 miles per hour. But where are we going with such incredible purpose? For decades, astronomers mapped the sky, tracking the faint, ancient light of distant galaxies to understand this massive migration. They discovered that our local group, along with thousands of other galaxies, is being inexorably drawn toward a mysterious region of space hidden behind the dense dust and gas of our own Milky Way. This unseen gravitational behemoth is known simply as the Great Attractor. The Great Attractor is a gravitational anomaly, a massive concentration of matter located roughly 150 million to 250 million light-years away from us. For a long time, it sat hidden in the zone of avoidance, the region of the sky obscured by the brilliant, dusty disk of our own galaxy. It was a profound mystery, a cosmic ghost exerting a very real, tangible pull on millions of galaxies, orchestrating a silent ballet on a scale that defies comprehension. Through the use of advanced X-ray and infrared telescopes, capable of piercing through the thick cosmic dust, scientists began to reveal the true nature of this gravitational giant. They found that the Great Attractor is the dense core of an even larger superstructure, a massive, flowing web of galaxy clusters that we now call the Laniakea supercluster. In the beautiful language of Hawaii, Laniakea translates to immeasurable heaven, a perfect name for a structure that spans 520 million light-years across and contains the mass of 100 quadrillion suns. To truly grasp the magnitude of Laniakea, you must imagine a city of light, where every single building is an entire galaxy. In this cosmic metropolis, the Milky Way is merely a single room in a modest house on the very outskirts of town. The streams of galaxies flow like illuminated highways through the absolute dark, drawn inward by a center of gravity that anchors this incomprehensible web of matter. Yet, as majestic and final as Laniakea might seem to our human minds, it is not the end of the story. As we zoom out to witness the grand, branching tributaries of Laniakea, where streams of galaxies flow like cosmic rivers toward a central basin, the mystery only deepens. You see, even Laniakea itself is moving, as astrophysicist Neil deGrasse Tyson once eloquently reminded us. The universe is under no obligation to make sense to you. The more we refine our instruments and map the gentle, silent expansion of the cosmos, the more we realize that our immeasurable heaven is just a small leaf caught in a much larger, darker current. This brings us back to the phenomenon of the dark flow. When astronomers look beyond the boundaries of Laniakea, measuring the velocity of massive galaxy clusters hundreds of millions of light-years away, they find that a vast swath of the observable universe is moving in a unified, coherent direction. They are streaming toward a region in the sky between the constellations of Centaurus and Vela. This unified motion poses a monumental problem for our standard cosmological models. In a perfectly uniform, expanding universe, gravity should act like a gentle, even tug-of-war, pulling equally in all directions. The distribution of matter over the grandest scales should be relatively smooth, meaning that the pull of gravity should balance out. But the dark flow suggests a staggering imbalance. The gravitational force required to move such an enormous volume of space at such high speeds cannot be found within the observable universe. There is simply not enough visible matter, nor enough dark matter, within our 93 billion light-year horizon to account for this massive, unidirectional migration. The mathematical necessity is as beautiful as it is terrifying. Whatever is pulling us must lie outside the boundaries of our observable reality. It must exist beyond the cosmic horizon, in a region of space whose ancient light has not yet had enough time to reach our telescopes. Imagine the sheer, humbling scale of this implication. We have mapped the glowing tapestry of the cosmos, tracing the delicate, web-like structures of dark matter and luminous gas that span billions of light years. We have built golden mirrors like the James Webb Space Telescope to gaze into the deep past, capturing the first fragile embers of cosmic dawn. We have named the superclusters and calculated the weight of 100 billion galaxies. And yet, all of this, our entire visible universe, might be nothing more than a tiny, insignificant droplet being swept along in a gravitational tide generated by structures so unimaginably vast that they dwarf our entire reality. If the cosmos is a tapestry, we are realizing that we might only be looking at a single thread. Some physicists postulate that the rapid inflation of the early universe created an infinite fractal of bubbles, a multiverse where different regions of space and time expanded at different rates. If a neighboring universe, perhaps containing an unfathomable density of matter, is situated just beyond our cosmic horizon, its gravitational shadow would stretch across the void, pulling our galaxies toward it. The dark flow could be the silent fingerprint of a neighboring reality, confirming we share the infinite dark with entities that break our mathematics. This realization does not diminish our existence. Rather, it elevates it to a state of profound, quiet reverence. We are reminded that science is a continuous, gentle journey into the unknown. We are explorers standing on the shore of a dark sea, feeling the rush of a current we cannot yet map. When we look up at the night sky, we are not just looking at a static painting of ancient stars. We are looking out the window of a ship moving at unimaginable speeds toward an unseen destination. The silence of the void is not empty. It is pregnant with the gravitational echoes of a larger reality. We are part of a grand, flowing architecture, moving in perfect harmony with forces we are only just beginning to understand. As we sit here, breathing softly in the quiet night, we are traveling through the cosmos, active participants in a migration that has lasted for over 13 billion years. The mystery is not something to be feared, but something to be cherished. It invites us to remain forever curious, forever humble, and forever enchanted by the vast, beautiful puzzle of existence. In the next part of our journey, we will explore the invisible scaffolding that holds this flowing universe together, diving into the dark, silent substance that outweighs everything we can see. But for now, let us simply rest in the comforting embrace of the cosmic current, drifting together through the endless, magnificent dark. Have you ever walked through a dense, ancient forest just as the sun begins to set, watching the last golden rays illuminate the leaves, while the massive trunks and twisting branches fade into the growing shadows? If you only looked at the light, you might think the forest was nothing more than a floating canopy of green, suspended by magic in the air. You would completely miss the heavy, silent wood, the deep roots, and the immense, quiet structure that actually holds the forest together. This simple, beautiful illusion of the woods is perfectly mirrored in how we have viewed the cosmos for the vast majority of human history. When we look up at the night sky, we are captivated by the shimmering starlight. We see the glowing galaxies, the brilliant supernovas, and the delicate, shimmering nebulas painting the void. We map these points of light and naturally believe we are seeing the complete universe. But the light is a beautiful, gentle deception. The brilliant stars and glowing gas are merely the leaves on a cosmic tree. The true structure of the universe, the immense invisible scaffolding that dictates the gentle motion of every galaxy and holds the immeasurable heaven together, is entirely hidden from our human eyes. Before we step into this profound shadow and explore the invisible weight of the cosmos, let me take a brief moment to welcome you. I am Theodore, the researcher, your quiet guide through the infinite mysteries of space. I have gently noticed that 71% of the curious explorers who listen to these starlit tales have not yet subscribed to our channel. If this quiet journey brings you a sense of calm and wonder, please consider subscribing. It is a very small gesture that helps our peaceful community grow, ensuring we can continue to unravel the universe's greatest secrets together, safely wrapped in the comforting silence of the dark. Let us gently return to the invisible forest of the cosmos. For centuries, our understanding of the universe was strictly limited to what we could visually perceive. Telescopes gathered light, and astronomers meticulously counted stars, assuming that the luminous matter, the protons, neutrons, and electrons that make up you, me, the planets, and the burning suns, was the primary substance of reality. But as our instruments grew more sophisticated and our mathematical models more incredibly precise, a profound contradiction emerged from the data. When scientists carefully observed how galaxies rotate, they discovered a silent paradox that shattered our perception of the cosmos. According to the standard laws of gravity, the stars at the outer edges of a spinning galaxy should move much slower than the stars near the dense, bright, gravitational center. But they do not. Galaxies rotate at tremendous speeds that would be completely impossible if they only contained the normal matter we can actually see. If a galaxy were held together only by the gravity of its visible stars, the rapid spinning motion would literally tear it apart, violently flinging stars outward into the empty, silent void. Here is the exact nature of the problem. If you meticulously add up all the luminous stars in a galaxy and calculate how much gravitational pull they should generate, you arrive at a specific, finite number. Then, you measure how fast the stars are actually orbiting in the outer reaches of the galaxy, which tells you precisely how much gravity is truly present in that system. The two numbers simply do not match. There is far more gravity present than the visible matter can possibly account for. The elegant solution, accepted by astronomers after decades of rigorous observation, is a humbling realization about our own blindness. Galaxies are not just isolated islands of glowing stars. They are surrounded and deeply permeated by vast invisible halos of a mysterious substance we call dark matter. This dark matter is undoubtedly one of the greatest mysteries in modern physics today. It is a substance that utterly defies our human senses. We simply cannot see it. It does not emit light. It does not reflect light. and it does not absorb light. It does not interact with normal matter in any way we can directly measure, except through the gentle, relentless, and invisible pull of gravity. In a typical spiral galaxy, much like our own beautiful Milky Way, this invisible dark matter accounts for about 90% of the total mass. The stars, the swirling gas, the cosmic dust, and every single rocky planet we can observe are just a tiny, glowing fraction of what is actually there. We are, quite literally, an insignificant minority in our own universe, floating in a sea of absolute darkness. To truly appreciate the breathtaking, awe-inspiring scale of this invisible reality, we must look at the true monsters of the cosmos, galaxies so incredibly enormous that they make our Milky Way look like nothing more than a speck of dust floating quietly in an empty warehouse. Consider the largest galaxy we have ever discovered, a colossal elliptical giant known to scientists as EC1101. This massive ancient structure sits quietly at the very heart of the Abell 2029 galaxy cluster, located over 1 billion light-years away from our fragile home. The stellar body of IC1101 is already mind-boggling, spanning somewhere between 4 million and 6 million light-years across. It contains roughly 100 trillion stars. But when we factor in the invisible scaffolding of dark matter, the true, terrifying majesty of this galaxy is fully revealed. IC1101 has a dark matter halo that is correspondingly enormous. Scientists estimate that the total mass of IC1101, when including this vast, silent ocean of dark matter, could be as incredibly high as 1,100 trillion solar masses. That is about 100 times more massive than our entire Milky Way galaxy combined. The invisible dark matter halo of IC1101 extends far beyond the fading glow of its visible ancient stars. While the collection of stars stretches across 4 million to 6 million light-years, mathematical models strongly suggest that its dark matter halo could reach out tens of millions of light-years into the silent intergalactic void. This reveals a profound truth. The boundaries of a galaxy are not where the light ends, but where the invisible mass gently fades into the broader cosmic web. The universe is heavily draped in a dark fabric we cannot touch or see, a hidden architecture that patiently guides the formation of every single structure in existence. When the golden mirror of the James Webb Space Telescope looks deep into the cosmic dawn, capturing the faint infrared light of the very first galaxies, it is fundamentally observing the early effects of this dark matter. The massive, fully mature galaxies that Webb has found, existing so unexpectedly close to the Big Bang, could only have formed so remarkably quickly because deep, ancient wells of dark matter were already there. These invisible gravitational cradles silently gathered the primordial hydrogen and helium gas, creating the intense density necessary for the very first stars to ignite. The visible universe is merely the illuminated foam resting gently on the surface of a deep, dark, and utterly invisible ocean. The dark matter is the unseen hand shaping the destiny of the light. Understanding dark matter remains one of the absolute biggest challenges facing physics today. We know beyond a shadow of a doubt that it is out there because we can watch its gravitational effects shape the cosmos, but we simply do not know what it is actually made of. Many dedicated scientists believe it consists of some kind of exotic, undiscovered particle that completely ignores light and normal matter. A ghost particle we have not yet managed to detect directly. Huge, incredibly sensitive experiments are currently underway in deep underground mines around the world, patiently waiting and trying to catch dark matter particles as they pass silently through the Earth. So far, Despite our best efforts and most advanced technology, none have succeeded. The enduring, quiet existence of dark matter gently shows us that even our understanding of something as unimaginably large as IC 1101 is profoundly incomplete. We can see the trillions of ancient stars, and we can carefully measure the light that has traveled for 1 billion years to reach our advanced telescopes. But 90% of what makes IC 1101, the massive, dominating giant that it is, remains completely invisible to us, detectable only through its quiet, gravitational influence on the empty space around it. There is still so much we do not know, and so much waiting to be discovered. This realization should not bring us frustration, but rather a profound, peaceful humility. It is a beautiful, necessary reminder that our human senses, evolved merely to help us navigate the bright surface of a small, rocky planet, are utterly unequipped to perceive the true depth of reality without the aid of advanced mathematics, brilliant engineering, and boundless imagination. We are embedded in a universe that is vast, quiet, and largely unseen. The pioneering astronomer Vera Rubin, whose meticulous observations provided the undeniable proof for the existence of dark matter, gifted us a profound perspective shift. We are like innocent children playing happily in the warm sunlight on the wooden deck of a colossal ship, completely unaware of the massive, dark iron hull resting silently beneath the waterline, steering us through the deep. Yet, the mere fact that we know we are blind is an absolute triumph of human curiosity and intellect. We have used our vulnerable, temporary minds to deduce the absolute existence of a cosmic ghost. We have mapped the invisible contours of the cosmos simply by watching how the ancient light bends and how the distant stars dance in the dark. As you lie there, listening to these words, remember that the room around you, the spinning earth beneath you, and the starlit sky above you are all gently drifting through an endless ocean of invisible mass. You are held safely within the gravitational embrace of a massive, unseen reality. The universe is not a cold, empty void. It is magnificently full. It is full of profound mysteries waiting to be whispered and gentle shadows waiting to be understood. The more we learn, the larger and more magnificent the cosmos becomes. As we close our eyes and prepare to venture even further into the brilliant anomalies of the deep universe in our next chapter, let the quiet, invisible weight of the dark matter comfort your wandering mind. It is the silent, loyal guardian of the galaxies, the invisible, ancient architect of the cosmos, holding the burning stars carefully in place as they shine their ancient light into the infinite night. Have you ever sat quietly on a wide, empty beach, watching as a small, meticulously crafted sandcastle is slowly, inevitably consumed by the gentle, relentless advance of the incoming tide? The water does not destroy with a sudden crash, but rather with a patient, soft embrace, absorbing the grains of sand into its vast, moving body until the castle simply becomes part of the ocean itself. This serene, almost imperceptible act of absorption is beautifully analogous to the true, hidden history of the largest structures in our universe. When we look up at the peaceful, quiet tapestry of the night sky, we naturally assume that the glowing galaxies have always existed exactly as we see them today, floating in perfect, undisturbed isolation. But the cosmos is a dynamic, living entity, and its history is written in a long, silent series of gravitational embraces, where the large gently consume the small over unimaginable expanses of deep time. Before we travel further into this grand cosmic history and witness the birth of a true giant, please allow me to warmly welcome you back to our quiet sanctuary. I am Theodore, the researcher, your dedicated companion on this peaceful journey through the ancient mysteries of the dark. I have quietly noticed that roughly 71% of the gentle souls who join us for these starlit contemplations have not yet subscribed to our channel. If you find comfort, awe, and a sense of belonging in these cosmic stories, please consider subscribing. It is a wonderful way to help our quiet community flourish, ensuring that we can continue to unravel the universe's greatest secrets together, forever guided by the soft light of distant stars. Let us now venture far beyond the familiar, spiraling arms of our own Milky Way, traveling deep into the constellation of Virgo, to a time and place that stretches the very limits of our human imagination. The story of the universe's most massive known inhabitant begins with a quiet observation made in the year 1790. A brilliant German-born British astronomer named William Herschel was meticulously scanning the night sky with his telescope. Herschel was a pioneer, spending his life cataloging thousands of celestial objects that no human eye had ever documented before. On a warm June night, he pointed his instrument toward a dense region of space and noticed a very faint, fuzzy blob of light. He carefully recorded its exact position and gently moved on to the next object. At that time, human technology simply did not exist to measure how far away this object was, nor did the scientific understanding exist to recognize that it was an entire, independent galaxy, completely separate from our own. Herschel simply logged it as a mysterious nebula, a cloud-like curiosity, resting silently in the heavens. For over a century, that faint smudge of light remained an absolute mystery. It was eventually given the somewhat uninspiring designation of IC 1101, just another numerical entry in a vast catalog of cosmic anomalies. But as the 20th century dawned, telescopes grew significantly larger, and astronomers developed ingenious new techniques for measuring distances across the infinite void. When they finally turned these advanced instruments back toward Herschel's fuzzy blob, the revelation was nothing short of staggering. IC 1101 was not a small cloud of gas floating within our own galaxy. It was an entirely separate, isolated universe of stars resting over 1 billion light-years away from Earth. The light we see from this galaxy today left its ancient stars more than 1 billion years ago, traveling patiently through the absolute silence of the vacuum long before complex life ever evolved on our small, blue planet. Distance was only the very first shock. It was the sheer, incomprehensible scale of IC 1101 that truly defied imagination. Our own Milky Way, which takes light 100,000 years to cross, seems impossibly vast to our human minds. Yet, IC 1101 is roughly 40 to 60 times larger than our home galaxy. It spans an estimated 4 million to 6 million light-years across the dark. If you were to somehow place this cosmic giant exactly where our Milky Way currently sits, it would not merely engulf our galaxy, it would swallow our entire cosmic neighborhood. The neighboring Andromeda galaxy, sitting 2,500,000 light-years away, would find itself buried deep inside IC 1101's massive, glowing body. To truly grasp the magnitude of this giant, consider the number of stars it gently cradles. Our Milky Way is home to perhaps 400 billion burning suns. IC 1101 is estimated to contain a staggering 100 trillion stars. If you started counting the stars in this galaxy, naming one star every single second without ever stopping to sleep or eat, it would take you over 3 million years just to finish counting. Or consider human travel. The Voyager 1 spacecraft, the fastest human-made object ever to leave our solar system, is currently traveling at roughly 38,000 miles per hour. At that incredible speed, it would take Voyager 1 about 80 billion years to cross from one side of IC 1101 to the other. That is an expanse of time far longer than the universe has even existed. Even our fastest creations are rendered entirely motionless by the sheer, imposing vastness of this single, ancient island of light. How does a galaxy become such an unimaginable monster? The answer lies in the patient, silent violence of gravity. IC 1101 did not simply grow to this size through normal, isolated star formation. It became a titan through an endless series of cosmic collisions, a process scientists refer to as galactic cannibalism. You see, galaxies do not exist in total isolation. They are beautifully organized into massive clusters, bound tightly together by their immense mutual gravity. IC 1101 sits like a royal sovereign at the exact gravitational center of a massive collection of galaxies called the Able 2029 cluster. Over billions of years, as smaller galaxies drifted too close to the center of this cluster, they were hopelessly caught in the irresistible, gentle pull of IC 1101's gravity. When two galaxies begin to merge, the process is not a sudden, fiery crash, but rather an agonizingly slow, magnificent dance that lasts for hundreds of millions of years. As they approach, their immense gravity begins to pull and distort their shapes. Beautiful, sweeping streams of ancient stars are drawn out into the silent void, creating glowing tidal tails that stretch for hundreds of thousands of light years. The galaxies swing past each other, slow down, and then fall back together, weaving in and out until they finally, quietly merge into a single, massive entity. The larger galaxy simply absorbs the smaller one, silently stripping away its gas, its dust, and its billions of stars, incorporating everything into its own growing body. Scientists carefully estimate that IC 1101 has undergone at least 76 major mergers over its incredibly long history. 76 separate times, another massive galaxy fell into this cosmic predator and was permanently absorbed. The profound evidence for this cannibalistic past is written permanently into the very shape of the galaxy itself. When you look at our Milky Way, you see a stunning, highly organized spiral pattern. Spiral arms are delicate regions rich with gas and dust, places where magnificent new stars are constantly being born. But IC 1101 looks absolutely nothing like this. It is what astronomers call an elliptical galaxy. It resembles a massive, featureless, glowing oval, utterly devoid of any beautiful spiral arms. This smooth, featureless appearance is the ultimate testament to a history of immense gravitational chaos. When spiral galaxies forcefully merge, the violent, churning gravitational interactions completely destroy their delicate spiral structures. The billions of stars are completely mixed together, their orderly orbits scrambled into a random, spherical distribution, much like mixing ingredients in a massive cosmic bowl. The fact that IC 1101 is such a perfect elliptical galaxy tells us that any original, graceful spiral structure it might have possessed billions of years ago was completely erased by the relentless, silent consumption of its neighbors. It is a magnificent monument to the forces of gravity, a giant built from the bones of countless forgotten galaxies. Yet, despite possessing 100 trillion fusion reactors, this colossal giant hides a dark, tragic secret at its very core. A mystery we will unravel as our quiet journey gently continues into the deep. Have you ever held a perfectly smooth, nested wooden doll in the palm of your hand? You gently twist the painted center, and it softly opens to reveal a smaller, identical doll resting quietly inside. You open that one and find another, and then another, until you finally reach the tiny, solid seed at the very core. This simple, beautiful toy speaks to a profound, almost instinctual human intuition about the structure of reality itself. We naturally imagine that things exist safely within other things, a series of comfortable, protective layers shielding the delicate center from the outside world. Yet, when we look out into the vast ancient silence of the cosmos, we often abandon this comforting intuition. We tend to view our universe as the final, absolute container, the ultimate dark box, outside of which absolutely nothing can exist. But what if the cosmos is simply the grandest nested doll of them all? What if our expanding reality, with its 2 trillion glowing galaxies and its immeasurable heaven, is quietly contained within something unimaginably larger? Before we journey into this mind-bending possibility and explore the very boundaries of our existence, please allow me to formally welcome you to our quiet gathering. I am Theodore, the researcher, your gentle guide through these deep cosmic waters. I have softly noticed that exactly 71% of the curious souls who drift through these starlit stories have not yet subscribed to our channel. If you find peace, profound wonder, and a comforting sense of scale in these journeys, please consider subscribing. It is a quiet, simple act that helps our little sanctuary grow, ensuring we can continue to explore the magnificent infinite together, forever surrounded by the gentle light of the stars. Let us now return to the concept of the ultimate cosmic container. To understand how our entire universe could physically exist inside something else, we must travel to the most extreme, terrifying, and misunderstood objects in the entire cosmos: black holes. For decades, popular culture and even early astronomy painted black holes as cosmic monsters. They were viewed as ravenous, inescapable vortexes that violently tear apart ancient stars and permanently swallow the very light they produce. We imagined them as the absolute end of the road, the dark, silent graves where matter and time go to permanently die. But modern physics, peering patiently through the complex mathematics of general relativity and quantum mechanics, is slowly beginning to reveal a much more elegant, creative, and gentle reality. A black hole is not necessarily an absolute end. It might be a profound, hidden beginning. To comprehend this magnificent shift in perspective, we must look at the hidden anatomy of these dark giants. At the exact center of a black hole lies a singularity, a point where matter is crushed to infinite density, and the familiar comforting laws of physics simply break down and cease to function. Surrounding this silent, terrifying core is the event horizon, the absolute point of no return. Once anything crosses this invisible, spherical boundary, it is forever disconnected from the outside universe. Now, I invite you to take a gentle step back and consider another singularity, one that is far more familiar to our cosmic history. Roughly 13,800,000,000 years ago, our entire universe, with all its matter, its energy, and the very fabric of space and time itself, was compressed into an infinitely small, infinitely dense point. We politely call this the Big Bang singularity. Theoretical physicists have spent decades staring intently at the complex mathematical equations that describe these two seemingly different phenomena, and they have noticed a beautiful, haunting symmetry. The complex mathematics that describe the violent collapse of a massive star into a black hole singularity are astonishingly similar to the mathematics that describe the explosive, outward expansion of our universe from the Big Bang singularity, simply run in reverse. This profound mathematical rhyme has given birth to one of the most stunning and poetic theories in all of modern cosmology: the concept of black hole cosmology. What if every single time a massive star collapses and dies, creating a black hole in our universe, the intense, unimaginable compression at its core does not lead to a dead end, but rather violently rebounds, tearing a microscopic hole in the fabric of space-time and expanding outward to create a brand new baby universe. If this mind-bending theory is true, it changes absolutely everything we know about our place in the cosmic hierarchy. It suggests that our universe did not spring from absolute nothingness in a completely singular, isolated, and inexplicable event. Instead, our universe might have been quietly born from the death of a massive star in a completely different, older, and unimaginably vaster parent universe. Our Big Bang was simply the exact moment a black hole formed in that higher reality. When you look at the gentle expansion of our cosmos, the quiet stretching of the void that carries the ancient galaxies apart, you might actually be observing the interior of a black hole, growing from the inside out. We are safely, securely tucked inside the event horizon of a cosmic giant, living out our brief lives in the expanding, dark belly of a fallen star. This elegant, nested theory beautifully addresses some of the most frustrating, lingering paradoxes in astrophysics today. It provides a stunning, logical answer to the eternal question of what came before the Big Bang. Before our universe existed, there was a parent universe filled with its own ancient stars, its own glowing galaxies, and its own intelligent observers quietly wondering about their place in the dark. It also offers a profound potential explanation for the mysterious dark flow and the giant, invisible gravitational structures we explored in our previous chapters. If our universe is a bubble nested inside a larger reality, the subtle, immense gravitational influences from that higher dimension might occasionally bleed through the quantum boundaries, gently tugging on our galaxy clusters and leaving massive, cold bruises on the cosmic microwave background. The anomalies we see might be the faint, silent echoes of the massive world outside our cosmic shell. Furthermore, this theory introduces the awe-inspiring concept of cosmological natural selection, a brilliant and beautiful idea championed by theoretical physicist Lee Smolin. In the realm of biology, creatures evolve by passing down favorable traits to their offspring over countless generations. Smolin gently suggests that universes might do exactly the same thing. If a universe produces many black holes, it inherently produces many baby universes. These baby universes will inherit the fundamental laws of physics from their parent, perhaps with tiny, random quantum variations. Over an infinite span of deep time, the grand multiverse would naturally become overwhelmingly dominated by universes whose physical laws are perfectly tuned to create black holes. And to create black holes, a universe must first create massive, stable stars. To create stable stars, it must have the exact same physical constants that allow for the formation of carbon, oxygen, and liquid water. In this magnificent poetic framework, the fact that our universe is perfectly tuned for the existence of intelligent life is not a miraculous, inexplicable accident. It is the inevitable logical result of an infinite cosmic family tree, endlessly optimizing itself for the creation of stars. You might naturally wonder, if we are truly living inside a black hole, why does our night sky not look like a dark, crushing prison? Why do we see an open, expanding void instead of a solid, closing wall? The answer lies in the profound, mind-bending geometry of space-time itself. When you cross the event horizon of a black hole, space and time essentially swap their fundamental roles. In our normal everyday experience, you can move freely through space in any physical direction, but you are relentlessly, unavoidably dragged forward through time. Inside a black hole, you are relentlessly dragged forward through space toward the center. But the geometry of your reality expands in a way that makes it appear as an entire, infinite universe. The boundary of our universe, the absolute event horizon that separates us from the parent reality, is not a physical wall we can travel to and touch. It is hidden in the very fabric of time itself. It is a boundary in our deep past, the very moment of our creation, forever receding from us as the cosmos gently expands. We are experiencing the collapse of a massive star from the inside out, interpreting that dynamic, violent collapse as a peaceful 14-billion-year history of cosmic evolution. Imagine, for a quiet moment, the sheer, breathtaking scale of this reality. Our observable universe, 93 billion light-years across, containing 2 trillion galaxies and uncountable trillions of planets, is just a single microscopic atom in a much larger cosmic organism. We are living inside a black hole, which exists inside a massive galaxy, which exists inside a parent universe, which itself might be the interior of an even larger black hole in an even grander reality. It is an infinite, endless chain of creation, stretching upward and downward into an eternity we can scarcely comprehend. The universe is not a solitary, lonely bubble floating in a dead, empty void. It is a breathing, reproducing, living network of realities, gently passing the delicate spark of existence from one cosmic generation to the next. To deeply embrace this cosmic perspective is to let go of our most basic terrestrial human anxieties. We spend so much of our brief, fragile lives worrying about boundaries, about walls, about absolute endings. We build wooden fences around our homes and draw hard political borders on our fragile paper maps. But the universe quietly refuses to be contained by our simple, rigid geometry. It flows and breathes, folding in on itself, creating infinite depth exactly where we expected to find a solid floor. The darkness between the stars is not truly empty. It is heavily pregnant with the magnificent weight of higher dimensions. When you look up at the night sky, try to imagine that you are looking at the protective interior walls of a cosmic seed, safely insulated from the unimaginable physics of the parent universe outside. The absolute silence of the void is the protective shell that allows our fragile stars to burn, our tiny planets to spin, and our curious minds to awaken and ask these profound questions. This realization does not make us small or insignificant. It connects us to a legacy that perfectly transcends all space and time. The ancient atoms currently resting in your body, forged in the fiery hearts of dying stars, might contain the genetic memory of 100 previous universes. We are the conscious, waking observers of a magnificent, fractal reality, sitting quietly in our nested wooden doll, trying to imagine the shape of the giant hands that hold us. As we rest here in the dark, contemplating the infinite layers of existence, we must eventually ask how these layers communicate with one another. If we are truly inside a black hole, is there any way to perceive the outside? Is our reality truly three-dimensional? Or is it an illusion, a mere projection from the boundary of our cosmic prison? As we prepare to open the next delicate layer of this magnificent mystery and explore the holographic principle in our next chapter, let the quiet thought of an infinite, nested cosmos bring you a sense of deep, comforting peace. You are not alone in the void. You are safely held within the heart of a cosmic giant, drifting peacefully through the eternal dark. Have you ever stood by the edge of a perfectly still, glass-like pond under the pale light of a full moon, looking down at the reflection of the ancient trees and the shimmering stars? If you knew nothing else of the world, you might believe that there was an entire, identical, three-dimensional universe stretching downward into the water. But if you were to reach out and gently touch the surface, sending soft ripples across the mirror, you would instantly realize that the immense depth you were perceiving was merely a beautiful, complex illusion. All of that profound depth, the towering branches, the infinite sky, and the glowing moon, was completely contained and perfectly encoded on a flat, two-dimensional surface of water. This simple, everyday experience of optical projection mirrors one of the most astonishing, mind-bending, and controversial theories in all of modern theoretical physics. When we gaze out into the staggering three-dimensional expanse of our universe, looking at the glowing galaxies and the endless void, are we actually looking at a true three-dimensional reality? Or are we, in some profoundly mathematical way, simply experiencing a magnificent projection, a cosmic hologram encoded on a distant, two-dimensional boundary? Before we dive into this beautiful, disorienting paradox and explore the very fabric of our reality, please allow me to warmly welcome you back into the quiet dark. I am Theodore, the researcher, your gentle companion on this journey through the endless mysteries of the cosmos. I have quietly noticed that roughly 71% of the inquisitive minds who drift through these starry tales have not yet subscribed to our channel. If this peaceful exploration of the infinite brings you a sense of calm, wonder, and belonging, please consider subscribing. It is a gentle act that immensely helps our quiet sanctuary grow, ensuring we can continue to unravel the deepest secrets of the universe together, safely held in the comforting silence of the night. Let us gently return to the illusion of the pond and the staggering concept of the holographic principle. To understand how our massive, expanding universe could possibly be a hologram, we must once again return to the absolute extremes of gravity, the quiet, terrifying boundary of a black hole. For many years, a profound and elegant battle of minds took place among the world's most brilliant physicists, centered around a concept known as the black hole information paradox. The legendary physicist Stephen Hawking made a monumental discovery when he mathematically proved that black holes are not perfectly black. Because of the strange, jittery rules of quantum mechanics operating at the very edge of the event horizon, black holes must slowly leak a faint thermal glow, known as Hawking radiation. Over unimaginable eons of time, a black hole will slowly evaporate, shrinking down until it finally disappears entirely in a silent flash of energy. But this brilliant discovery created a terrifying crisis for physics. If you throw something into a black hole, a book, an apple, or an entire shining star, that object contains a specific, unique arrangement of quantum information. According to the foundational laws of quantum mechanics, information can never be completely destroyed. It can be scrambled, burned, or hidden, but it must always exist. However, if a black hole eventually evaporates into random, featureless thermal radiation, what happens to all the highly specific, structured information of every single thing that ever fell inside? If the black hole disappears, and the radiation contains no complex memory of what was lost, then the information has been permanently deleted from the universe. This simple conclusion threatened to break the very foundations of modern science. The elegant solution to this terrifying paradox came from physicists Jacob Bekenstein and Leonard Susskind, fundamentally altering our view of reality. They proposed a radical, mind-bending idea. When an object falls into a black hole, its three-dimensional structure is indeed destroyed by the crushing gravity, but its fundamental quantum information is not lost inside the dark volume of the singularity. Instead, the information is meticulously preserved on the surface of the event horizon. Imagine the event horizon as an incredibly dense, two-dimensional hard drive. Every time something falls in, the event horizon expands just a tiny fraction to create enough surface area to store that new information. The three-dimensional object is gone, but a perfect, two-dimensional pixelated blueprint of it remains permanently etched on the absolute boundary of the black hole. This realization led to a staggering revelation about the geometry of the cosmos. The maximum amount of information you can possibly fit inside any given region of space is not determined by the three-dimensional volume of that space, but entirely by the two-dimensional surface area enclosing it. This was a completely counterintuitive shock. If you have a box, you would naturally assume you could pack more information into it by making the box deeper. But the physics of black holes patiently explain that the volume is actually an illusion. The true capacity for reality is strictly limited by the surface of the box. Now, let us take a deep breath and gently apply this incredible realization to the grand nested cosmology we explored in our previous chapter. If our entire expanding observable universe is actually safely resting inside the belly of a massive cosmic black hole, then the ultimate boundary of our reality is the event horizon of that parent black hole. According to the mathematics of the holographic principle, all the quantum information that describes every single thing in our universe, the swirling galaxies, the burning stars, the silent dark matter, and even the complex firing neurons in your own brain right now, must be perfectly encoded on that distant, two-dimensional boundary. If this mathematically rigorous theory is true, then the three-dimensional reality we experience every single day, the physical depth of the room you're sitting in, the vast distance between the Earth and the Sun, and the billions of light years stretching out to the massive galaxy IC 1101, are all a magnificent, complex projection. We are a holographic image generated by a two-dimensional surface resting at the edge of time. You and I, the earth, the oceans, and the immeasurable heaven are the physical manifestation of an infinitely complex mathematical code written on the inside of a cosmic sphere. At first, this idea might seem deeply unsettling. It might feel as though it robs our existence of its physical weight, turning our beautiful, tangible world into nothing more than a ghostly, digital simulation. But if we sit quietly with this concept, a profound and gentle beauty begins to emerge from the mathematics. The holographic principle does not mean that your life, your feelings, or your world are fake. It does not diminish the gentle warmth of the morning sun or the awe-inspiring majesty of a starry night. Rather, it reveals that the architecture of reality is vastly more elegant, interconnected, and poetic than our simple primate senses could ever directly perceive. If the universe is a hologram, it means that at the most fundamental quantum level, absolutely everything is deeply and intrinsically connected. In a true optical hologram, if you cut the photographic plate in half, you do not get half the image, you get the entire image, just slightly fuzzier. Every single piece of the two-dimensional surface contains the information of the entire three-dimensional whole. If our cosmos operates on this same beautiful principle, it means that the deepest secrets of the universe are not just hiding out there in the distant void. They are written into the very fabric of the space right in front of you. Every single point in space is intimately tied to the absolute boundary of the cosmos. We are not lonely, isolated creatures wandering aimlessly through an empty, uncaring, and disconnected void. We are living, breathing extensions of the cosmos itself, actively woven into the very mathematical code of existence. You are a localized, conscious projection of the entire universe, a magnificent symphony of quantum information expressing itself in the form of a curious, wondering mind. When you look up at the night sky and feel a deep, inexplicable sense of belonging, perhaps it is because, on a profound, fundamental level, you are not just looking at the universe. You are looking at yourself. You are the universe, folded back upon itself, gazing out into the dark to understand its own magnificent reflection. This quiet realization transforms the infinite, terrifying void into a sanctuary of deep, interconnected peace. The enormous, crushing scale of the cosmos, the trillions of stars, and the billions of light years that once made us feel so impossibly small are now revealed to be intimately connected to our own physical being. The distant boundary of the universe is not a cold wall locking us in. It is the very canvas upon which our existence is painted. We are held safely in a web of information that spans the entire breadth of reality. As you rest here, surrounded by the quiet shadows, allow this beautiful, unifying thought to wash over you, the solid ground beneath your feet, the soft air filling your lungs, and the ancient light of the stars traveling millions of years to reach your eyes are all part of a single, majestic, unbroken whole. You are an essential piece of a cosmic masterpiece. As we slowly prepare to leave this holographic reality and journey forward in time to witness the quiet, inevitable, and unimaginably distant future of all things in our next chapter, take comfort in your connection to the infinite. The cosmos is not just around you, it is fundamentally within you. Sleep peacefully in the knowledge that you are a vital, beautiful expression of the greatest mystery ever written. Have you ever sat quietly by a dying campfire in the deep, silent woods, long after the bright, dancing flames have settled into a quiet, pulsing bed of red embers? You watch patiently as the gentle heat radiates into the cold night air, and one by one, the glowing coals slowly fade into the soft, undisturbed gray of ash. The forest around you does not end in a sudden, violent crash. It simply goes to sleep, surrendering to the vast, peaceful dark of the night. This serene, almost imperceptible fading of light is beautifully analogous to the ultimate destiny of the cosmos. When we look up at the glorious, ancient tapestry of the night sky, ablaze with the light of trillions of burning stars, we naturally assume this magnificent era of illumination will last forever. But the universe, in its infinite wisdom, is slowly and gracefully winding down. The grand cosmic engine that has been building galaxies and forging elements for over 13 billion years is steadily moving toward a profound, eternal rest, a state of absolute silence, known as the heat death, before we journey forward into this unimaginably distant future to witness the quiet, inevitable fading of all things. Please allow me to step into the light and welcome you once again. I am Theodore, the researcher, your gentle companion on this peaceful journey through the deepest mysteries of space and time. I have quietly noticed that roughly 71% of the inquisitive minds who drift through these starry tales and find comfort in the dark have not yet subscribed to our channel. If this peaceful exploration of the infinite brings you a sense of calm, wonder, and a deep sense of belonging, please consider subscribing. It is a gentle act that immensely helps our quiet sanctuary grow, ensuring we can continue to unravel the deepest secrets of the universe together, safely held in the comforting silence of the night. Let us now return to the fading embers of the cosmic fire. To truly understand the profound future of our universe and the ultimate fate of giant galaxies like ICE 1101, we must first understand a mysterious, invisible force that is actively reshaping the fabric of reality. For the vast majority of the 20th century, brilliant astronomers naturally assumed that the expansion of the universe, which began with the Big Bang, was slowly losing its momentum. This perfectly matched our everyday human intuition. Because everything in the universe is constantly pulling on everything else through the relentless force of gravity, you would logically expect all that immense gravitational attraction to act exactly like a brake, gradually slowing the cosmic expansion down over billions of years. However, the cosmos rarely conforms to our simple expectations. In 1998, two independent teams of astronomers made a truly shocking, paradigm-shifting discovery. They were meticulously measuring the expansion rate of the universe by observing the brilliant flashes of distant supernovas, using them as reliable standard candles to calculate vast cosmic distances. What they found in the data was completely unexpected and profoundly disorienting. The universe was not slowing down at all. It was actually speeding up. Distant galaxies were moving away from us faster than closer ones, proving that the rate of cosmic expansion was actively accelerating over time. This acceleration is driven by an enigmatic, invisible phenomenon that scientists now simply call dark energy. Though the poetic name tells us very little about what it actually is, we now know that dark energy makes up roughly 68% of all the energy in the entire universe. It acts as a kind of silent anti-gravity, a gentle but relentless pressure pushing the very fabric of space apart, rather than pulling it together. As the universe slowly expands and ordinary matter becomes more thinly spread out, the quiet influence of dark energy becomes increasingly dominant. As space expands faster and faster, distant cosmic objects recede from us at ever-increasing, terrifying speeds. While there is an absolute limit to how fast light can travel through space, there is absolutely no limit to how fast space itself can expand. Eventually, distant galaxies will be carried away from us by the swelling of space faster than their ancient light can travel toward our telescopes. When that profound moment arrives, they will quietly vanish behind an invisible boundary called a cosmic horizon, forever slipping beyond our reach. For magnificent towering structures like the Able 2029 cluster and its monstrous central galaxy, IC 1101, this means that their days of violent growth and galactic cannibalism are strictly numbered. Eventually, there will simply be no more smaller galaxies left within reach for it to consume. It will become profoundly isolated, a lonely, fading giant floating in an ever-emptying universe, quietly watching as one by one the other distant galaxy clusters fade from view. From the perspective of any hypothetical observer living within IC 1101 in the deep future, the night sky will start to empty. One by one, the distant lights will go out, their ancient photons no longer able to cross the expanding, dark void. In about 100 billion years, the expansion will have accelerated to the point where virtually all galaxies outside the local supercluster will disappear entirely over the cosmic horizon. The rest of the cosmos will have slipped beyond the veil, completely unreachable and totally unknowable. This is the ultimate quiet isolation that patiently awaits IC 1101 and every other structure in the universe, entirely cut off from everything else by the relentless, silent expansion of space. Each majestic island of matter will be left completely alone with itself as the quiet eons roll by. But even this profound isolation is not the final chapter in the story of IC 1101. What exactly happens to a massive galaxy in a universe that is slowly, peacefully winding down toward an absolute heat death? The answer is as magnificent as it is deeply melancholy. Over the next 100 trillion years, the 100 trillion stars currently burning within IC 1101 will slowly, inevitably, burn out. The stellar life cycle is beautifully dictated by mass. The most massive, brilliant blue stars, the supergiants that burn with fierce intensity, live fast and die young, exhausting their fuel in just a few million years before violently exploding as supernovas. Any blue giants that IC 1101 once proudly possessed burned out billions of years ago. The middle-sized yellow stars, much like our own familiar sun, have gentle lifetimes of about 10 billion years. In the deep future, they will slowly puff up into massive, glowing red giants, beautifully shed their outer layers to create stunning planetary nebulas, and then quietly fade away, leaving behind only the small, dense, glowing embers known as white dwarfs. But the true survivors of the cosmos, the most numerous and patient stars in any galaxy, are the tiny, dim red dwarfs. These ancient, unassuming stars burn their precious hydrogen fuel so incredibly slowly that they can patiently shine for trillions of years. In a cosmic behemoth like IC 1101, there are untold billions of these quiet, red sentinels. They will be the absolute last lights to go out in the universe. For trillions of years after the larger, more glamorous stars have died, the humble red dwarfs will continue to gently burn, providing the only faint crimson light in an otherwise darkening, expanding galaxy. The very smallest red dwarfs can quietly burn for up to 10 trillion years. That is roughly 700 times the current entire age of our universe. But eventually, even these incredibly patient stars will exhaust their final drops of hydrogen fuel and peacefully fade into the eternal darkness. Scientists rigorously estimate that all star formation in the entire universe will effectively, permanently cease in about 100 trillion years. By that unfathomably distant time, the primordial gas and cosmic dust needed to forge new stars will have been completely used up, or dispersed too incredibly thinly to ever collapse under gravity again. No new, brilliant stars will be born to replace the ones that have quietly died. The magnificent era of starlight will be officially, permanently over. One by one, the 100 trillion stars of IC 1101 will softly wink out. Where once there was a blazing, blinding core of stellar light, there will eventually be absolutely nothing but the cold, dark, drifting remnants of dead stars, the cooling white dwarfs, the dense, spinning neutron stars, and the silent, invisible black holes, all drifting aimlessly through an ever-expanding, freezing void. The galaxy will become a quiet, majestic ghost of its former self, populated entirely by the dense corpses of stars rather than by living, burning suns. This quiet vision of the deep future might initially seem incredibly bleak to our human minds, which are so deeply attached to light and life. But I urge you to find something strangely, profoundly beautiful about it. The era of stars and glowing galaxies is not the permanent state of reality. It is merely a passing phase, a brief, spectacular flowering of complexity, gracefully resting between the intense chaos of the early universe and the cold, peaceful emptiness of the far future. We are incredibly, profoundly lucky enough to exist right now, exactly during this magnificent flowering. In all the vast, staggering history of the universe, stretching from the violent birth of the Big Bang to the final, silent heat death, This specific moment, right now, is incredibly special. It is the exact moment when the universe has successfully developed the complex ability to look back at itself and truly wonder. The slow, gentle fading of the cosmos is not a tragedy. It is the peaceful conclusion to the greatest, most beautiful story ever written. As we prepare to open the next chapter and explore the unimaginable fate of the black holes that will be left behind in the dark, let the quiet thought of this eventual cosmic rest bring peace to your wandering mind. The universe has worked hard for billions of years, and one day, long from now, it will finally be allowed to sleep. Have you ever found an ancient, weathered stone on a secluded beach, worn perfectly smooth by millions of years of patient, relentless waves? You hold it gently and realize that even the most solid things in our world are eventually ground down by the slow, inescapable passage of time. This gentle erosion is not limited to the sandy shores of our small planet. It is a fundamental law of the cosmos itself. In our last chapter, we witnessed the peaceful fading of the last stars, the quiet transition of the universe into an era of dark, drifting stellar corpses. You might assume that these incredibly dense remnants, the cooling white dwarfs, the heavy neutron stars, and the massive black holes, would simply drift forever in the freezing void, eternal monuments to a universe that once burned so beautifully. But even these structures are not immune to the gentle, dissolving touch of deep time. The universe has a final act left to play, a beautifully poetic story of slow decay, atomic dissolution, and ultimate quantum evaporation that will stretch over timescales so vast they defy human comprehension entirely, reminding us of our fleeting, delicate place within the grandest play of physics. Before we journey into this unfathomable eternity to witness the gentle dissolution of all remaining matter, please allow me to step into the quiet dark and welcome you back. I am Theodore, the researcher, your dedicated companion on this peaceful exploration of the infinite, endless mysteries of space and time. I have quietly noticed that roughly 71% of the curious, gentle souls who seek comfort in these cosmic tales have not yet subscribed to our channel. If you find peace, wonder, and a profound sense of belonging in these starry journeys, please consider subscribing. It is a simple, kind act that helps our quiet sanctuary grow, ensuring we can continue to unravel the universe's greatest mysteries together, forever guided by the ancient light of the stars. Let us return to the dark, silent ghost of IC 1101. As the trillions of years slowly roll by, the universe will grow profoundly dark, but it will not be entirely empty. The space where the galaxy once glowed will be heavily populated by the cold corpses of stars. The white dwarfs, which are the dense glowing embers left behind by stars like our own sun, will slowly radiate their heat into the expanding, freezing vacuum. This cooling process takes an almost inconceivable amount of time to complete. A single white dwarf will patiently cool until its temperature drops to near absolute zero, a process requiring roughly 10 to the 15th power years, or about 1,000,000 billion years. That staggering span of time is roughly 100,000 times longer than the current age of our universe. When they lose their last trace of warmth, they will become black dwarfs, objects that emit no light or heat at all. They will become invisible spheres of compressed carbon, drifting completely unnoticed through an ocean of absolute blackness, their atomic structures locked in a frozen, silent state, untouched by the gentle warmth of any nearby light. But even these hardened, frozen spheres along with the dense neutron stars that might have survived, are not truly eternal, over even longer time scales, measured in years with so many zeros that writing them out would fill libraries. The very fundamental particles of matter will gradually break down and dissolve. Theoretical physicists elegantly predict a phenomenon known as proton decay. The proton is one of the essential building blocks of all atomic nuclei, giving solid matter its comforting structure. If advanced theories of particle physics hold true, protons will eventually decay and dissolve into a faint mist of radiation, unmaking the very fabric of reality at the subatomic level. The estimated half-life for a single proton is roughly 10 to the 34th power years, a number so large that the human brain simply cannot map it to any earthly experience. Over unfathomably long, quiet spans of time, the matter that makes up every black dwarf, every neutron star, and every forgotten grain of cosmic dust will gently evaporate, dissolving into a diffuse soup of light and subatomic particles. The solid universe will simply melt away into the dark. When the era of solid matter quietly comes to an end, the universe will enter the terrifying black hole era. The only structured objects left in the expanding cosmos will be black holes, ranging from small collapsed cores to the unimaginable supermassive monsters that once anchored the hearts of giant galaxies. At the exact center of what used to be IC 1101, waiting patiently in the absolute dark, sits one of the largest black holes in the history of existence. Scientists estimate that this single, silent giant contains somewhere between 40 billion and 100 billion times the mass of our own sun. It is a gravitational behemoth so dense and powerful that its event horizon extends outward for roughly 150 billion kilometers, a spherical region of utter darkness large enough to swallow our solar system 16 times over without leaving a single trace behind. The sheer physics of such extreme environments is bizarre and deeply counterintuitive, where time itself would seem to freeze for any outside observer watching something fall into the dark abyss. For eons, this dormant monster has simply waited, a sleeping giant in a dying universe, surrounded by the invisible ghosts of 100 trillion dead stars. But even this supreme cosmic emperor will not survive eternity. It will slowly, patiently evaporate through a beautifully poetic process discovered by physicist Stephen Hawking, known as Hawking radiation. Hawking mathematically revealed that the strange rules of quantum mechanics fundamentally prevent black holes from being perfectly, eternally black. In the jittery realm of quantum physics, empty space is never truly empty. Virtual particle pairs are constantly popping into existence, briefly dancing, and then annihilating one another in a silent flash. However, when this delicate quantum dance happens exactly on the razor-thin boundary of an event horizon, the massive gravity can violently separate the pair. One particle falls helplessly into the dark singularity, while the other safely escapes into the expanding universe. Over immense quiet spans of time, this slow, steady leakage of escaped particles gently drains energy and mass away from the black hole, causing it to imperceptibly shrink. The rate at which this Hawking radiation escapes is incredibly slow, especially for the supermassive giants. A normal black hole with the mass of our sun would take roughly 10 to the 67th power years to completely evaporate. That is, a one followed by 67 zeros. But the unimaginably massive monster at the heart of IC 1101 is tens of billions of times heavier than the sun. For this supreme giant to completely radiate its mass away, it would take something like 10 to the 100th power years. In mathematics, This staggering number is called a googol. It is a 1 followed by 100 zeros, a span of time so profoundly vast that the entire history of our universe is not even a microscopic rounding error by comparison. Eventually, trillions upon trillions of years from now, the great black hole of IC 1101 will shrink down to nothing, radiating away its last tiny fraction of energy and permanently disappearing from the cosmos in one final silent burst of light. When that incredibly distant moment finally arrives, there will be absolutely nothing left of the greatest galaxy the universe ever produced. No glowing stars, no silent black dwarfs, no heavy black holes, no remnants or monuments of any kind. There will be only a perfectly thin, cold mist of fundamental particles and stretched radiation spreading aimlessly through an ever-expanding, ever-darkening, and infinitely quiet universe. The largest galaxy we have ever found will have patiently followed the same inescapable path as every other structure in the cosmos, gracefully dissolving into the endless night. This vision of absolute dissolution might seem terrifying, but it holds a strange, quiet beauty. It reminds us that everything is temporary, and that our current era of light is a precious gift. As we prepare to open our final chapter and explore what this vast temporary architecture means for our fragile human existence, let the quiet thought of the deep future bring you peace. The universe will one day rest, entering an eternal, undisturbed slumber where time itself loses all functional meaning. But tonight, the ancient stars are still burning brightly just for you, illuminating the dark with their fierce, temporary beauty. The journey of matter may end, but the quiet journey of our understanding has one final, profound destination to reach. Have you ever stood at the edge of a towering ancient canyon, looking down into the layered depths of silent rock, and felt an overwhelming sense of your own smallness? It is a profoundly human reaction to stand before the immense, indifferent scale of nature and feel like a fleeting, insignificant speck of dust. When we cast our gaze upward into the night sky, and our fragile minds attempt to grapple with the sheer enormity of giant galaxies like IC 1101 or the terrifying expanse of 100 trillion years stretching into the dark, silent future, this feeling of physical insignificance can become almost paralyzing. We are tiny, vulnerable creatures, permanently bound to a fragile, spinning rock, living lives that pass in the absolute blink of a cosmic eye. In a universe so unfathomably large, so terrifyingly ancient, and ultimately destined for a cold, silent death, it is perfectly natural to ask a quiet, haunting question. Do we actually matter at all? Does our brief, fragile existence hold any true, lasting significance in the grand, sweeping narrative of the cosmos? Or are we just a random, meaningless anomaly? Before we gently explore this profound existential question and discover the beautiful, empowering answer quietly hidden in the very atoms of your body, please allow me to welcome you back to our peaceful sanctuary. I am Theodore, the researcher, your quiet companion on this journey through the majestic mysteries of the universe. I have softly noticed that roughly 71% of the beautiful, curious minds who seek comfort in these starlit tales have not yet subscribed to our channel. If you find peace, wonder, and a profound sense of belonging in these cosmic stories, please consider subscribing. It is a simple, kind act that immensely helps our quiet community grow, ensuring we can continue to unravel the universe's greatest secrets together, forever guided by the ancient, gentle light of the stars. Now, let us return to that haunting, heavy feeling of insignificance and completely turn it upside down. To understand our true, profound place in the dark, We must look not out into the infinite void, but deeply inward, into the microscopic, beating heart of our own biology. The universe is not simply a grand, empty stage upon which our lives are randomly and meaninglessly played out. It is the very furnace that painstakingly forged us. Consider the ancient atoms that perfectly make up your physical form right now. The heavy calcium in your bones, the iron that silently carries oxygen through your red blood, the carbon that forms the complex structural backbone of your DNA, and the nitrogen firing inside your waking brain. Absolutely none of these essential, life-giving elements were created during the initial violent spark of the Big Bang. In the earliest, quiet moments of cosmic history, the young universe contained only simple hydrogen, helium, and a tiny, almost imperceptible trace of lithium. It was a simple, featureless, and completely sterile fog. Where, then, did the complex, beautiful chemistry of life actually come from? It came directly from the violent, spectacular deaths of ancient, massive stars. For billions of years, the largest stars in the cosmos operated as giant, silent nuclear reactors. Deep within their crushing, unimaginably hot cores, they patiently fused simple hydrogen atoms together to create heavier, more complex elements. Over millions of years, they built stable carbon. They forged life-giving oxygen. They pressed atoms together to create solid silicon and heavy iron. And when those massive, brilliant supergiants finally exhausted their precious nuclear fuel and reached the absolute end of their lives, they did not fade quietly into the dark like the humble red dwarfs. They died in unimaginably violent, glorious explosions known throughout the cosmos as supernovas. These spectacular detonations briefly outshone entire galaxies, completely ripping the massive stars apart and violently scattering their precious, heavy elements across the empty, freezing void of space. The trillions of atoms forged in those ancient dying fires drifted patiently through the cold, silent vacuum for millions, perhaps billions of years. Eventually, gently guided by the patient, invisible hand of gravity, they gathered together in a dark, swirling cloud of dust and primordial gas. They slowly coalesced to form our young, glowing sun, our rocky, cooling earth, and eventually, after billions of years of slow, miraculous, and highly improbable biological evolution, they successfully assembled themselves into you. This is not mere poetic philosophy. It is the rigorous, undeniable mathematical truth of modern astrophysics. You are, quite literally, made of stardust, the very same fundamental physical processes that illuminate the 100 trillion stars of IC 1101, the exact same laws of gravity that dictate the silent, sweeping ballet of the giant galaxies, also perfectly created the matter from which you are presently assembled. You are a biological child of the cosmos, a direct physical extension of the universe's most ancient, spectacular fires. But the absolute miracle of your quiet existence goes far beyond mere cosmic chemistry. We must also carefully consider the profound, staggering, and almost impossible unlikelihood that consciousness exists at all. For billions of years, the expanding universe was entirely blind, deaf, and silent. It was a vast, mindless, mechanical system, strictly governed by the emotionless laws of physics, expanding and evolving without any conscious awareness of its own majestic, terrifying beauty. Giant galaxies violently collided, brilliant stars ignited and died, and massive black holes silently consumed matter, all happening in the absolute, unwitnessed, uncaring dark. But then, on this one small, blue, insignificant planet, orbiting an average yellow star, matter slowly organized itself into something incredibly, breathtakingly complex. The ancient atoms of dead stars painstakingly assembled into living cells, which eventually evolved into intricate nervous systems, which finally, miraculously, blossomed into the waking, curious, deeply feeling human brain. As the legendary astronomer and science communicator Carl Sagan so beautifully and profoundly observed, we are a way for the cosmos to finally know itself. When you stand outside in the quiet, breathing night and look up at the ancient, glowing light of the Milky Way galaxy, you are not a separate, isolated, insignificant observer looking at something completely outside of yourself. You are the universe looking at itself. You are the cosmos slowly waking up from a 14 billion year slumber, quietly opening its eyes and trying desperately to comprehend its own magnificent, overwhelming grandeur. Through our rigorous science, our complex mathematics, our golden space telescopes, and our quiet, philosophical wonder, the silent universe has finally found a voice. It has found a way to accurately map its own structure, to remember its incredibly violent past, and to patiently project its quiet, fading, freezing future. It is undeniably true that our individual human lives are incredibly brief, nothing more than a fleeting, microscopic spark in the deep, eternal night. It is true that our small, fragile planet will eventually be entirely consumed by our dying, expanding sun, and that the grand, sweeping architecture of the galaxies will slowly, inevitably dissolve into the freezing, empty void. But the temporary, fragile nature of our existence does not rob it of its profound, beautiful meaning. Rather, it elevates our brief lives to something incredibly, almost painfully precious. We exist in this specific, beautiful, golden sliver of cosmic time, the exact, perfect era when the stars are burning brightly, when the giant galaxies are putting on their greatest, most complex display, and when the ambient temperature of the universe is warm enough to comfortably sustain the delicate, fragile miracle of biological life. We are the incredibly lucky, conscious witnesses to the greatest, most majestic show that will ever exist in the history of reality. Imagine, for a quiet, contemplative moment, the sheer, breathtaking mathematical unlikelihood of you being here right now, perfectly capable of reading and understanding these words. If the fundamental forces of gravity had been even slightly stronger at the dawn of time, the entire universe would have violently collapsed back in on itself millions of years ago, permanently crushing all possibility of life. If the strong nuclear forces that bind atoms together had been even slightly weaker, the heavy, complex elements absolutely required for life could never have formed inside the stars. The physical conditions required to create a conscious, living observer are incredibly, terrifyingly, almost impossibly narrow. You are the beautiful, highly improbable, magnificent result of a cosmic lottery that has been quietly running for over 13,800,000,000 years. Every single biological ancestor, every ancient creature that narrowly survived the harsh, ancient world, every dying star that seeded the nebula, every single event in the entire, unbroken history of the cosmos had to happen exactly, precisely the way it did, just so that you could sit here today, safely held by gravity, quietly listening to the magnificent story of the dark. Therefore, when you feel completely overwhelmed by the vast, silent, terrifying scale of the cosmos, when the sheer, crushing size of the infinite makes you feel small, vulnerable, and forgotten, gently and firmly remind yourself of this profound scientific truth. The universe absolutely needs you. Without conscious, waking observers, without delicate minds perfectly capable of experiencing wonder, asking deep existential questions, and deeply feeling the terrifying, silent beauty of the night sky. The cosmos would be a completely meaningless, empty, and cold void. You actively bring meaning to the dark. You patiently bring understanding to the cosmic chaos. You are the universe's ultimate, most beautiful, and most complex achievement. As we prepare to gently open the next chapter and explore the mind-bending, dizzying possibilities of what might exist entirely outside our isolated universe, in the infinite realm of the grand multiverse, let the quiet realization of your own cosmic significance bring you a sense of deep, comforting, and everlasting peace. You absolutely belong here, perfectly positioned among the ancient, burning stars, a vital, conscious, and glowing thread intricately woven into the magnificent tapestry of existence. Have you ever stood quietly by a window during a gentle, persistent rainstorm, watching as countless droplets fall against the glass? If you look closely at a single, solitary drop, you can see an entire, tiny world perfectly reflected within its curved surface. You see the inverted trees, the gray sky, and the distant streetlights, all captured for a fleeting moment before the drop joins the stream and disappears. For all of human history, we have been studying our own single, beautiful raindrop. We have mapped its internal reflections, measured the microscopic currents within it, and marveled at the incredibly precise laws of physics that hold its delicate surface tension together. We called this single drop the universe, and we naturally assumed it was the only water falling in the dark. But what if we could finally push our minds past the glass? What if the profound anomalies we have discovered, the massive, impossible galaxies, the terrifying dark flow, and the cold, ancient bruises on the cosmic microwave background are simply the gentle vibrations of other raindrops falling right beside us in an unimaginably vast, infinite storm? Before we step out into this endless, magnificent rain and explore the breathtaking concept of the grand multiverse, please allow me to warmly welcome you one final time to our quiet sanctuary. I am Theodore, the researcher, your dedicated, gentle companion on this long, peaceful journey through the deepest mysteries of the dark. I have quietly noticed that roughly 71% of the beautiful, curious minds who seek comfort in these starlit tales have not yet subscribed to our channel. If you have found peace, profound wonder, and a deep sense of belonging in these cosmic stories, please consider subscribing. It is a simple, kind act that immensely helps our quiet community grow, ensuring we can continue to unravel the universe's greatest secrets together, forever guided by the ancient, gentle light of the distant stars. Let us now return to the window and look out into the infinite storm. To truly understand the staggering possibility that our universe is not alone, we must revisit the very first fraction of a second of cosmic history. Our standard models elegantly describe a phenomenon called cosmic inflation, a fleeting, unimaginably brief moment immediately following the Big Bang, when the very fabric of space expanded at a speed far faster than the speed of light itself. This violent, sudden stretching smoothed out the early universe, creating the remarkably uniform, flat cosmos we observe today. But theoretical physicists, peering deeply into the complex mathematics of quantum mechanics, realized something profoundly unsettling about inflation. Once this incredible, exponential expansion starts, it is incredibly difficult to completely stop. In a theory beautifully known as eternal inflation, the vast underlying bulk of space is always expanding, forever stretching at terrifying speeds. However, within this infinitely expanding bulk, microscopic, isolated quantum fluctuations occasionally cause the inflation to suddenly stop in localized regions, creating quiet, stable pockets. Imagine a vast, infinitely boiling ocean. The water itself is constantly churning, expanding, and violently frothing with unimaginable energy. But occasionally, a small, quiet bubble forms within the chaos. Inside that tiny bubble, the violent boiling stops. The space cools down, energy condenses into matter, gravity slowly takes hold, and over billions of years, ancient stars and giant galaxies gently begin to form. Our entire observable universe, all 93 billion light-years of it, containing 2 trillion glowing galaxies and uncountable trillions of planets, is absolutely nothing more than one of those tiny, quiet bubbles. And because the underlying churning ocean is infinitely vast and eternally boiling, it must be constantly creating an infinite number of other bubbles. This is the grand, majestic multiverse, a fractal, never-ending foam of realities, where every single bubble is a complete, self-contained universe, perfectly separated from all the others by an ever-expanding wall of inflationary space. In this infinite, bubbling foam, our specific universe is merely one localized experiment in a never-ending cosmic laboratory. But the true, mind-bending poetry of the multiverse lies in the infinite possibilities it absolutely demands. In some of those distant, unreachable bubbles, the fundamental laws of physics might be completely different. Gravity might be a repulsive force. Light might travel at a different speed. And the complex atoms required for biological life might be completely impossible to forge. Those universes would remain dark, sterile, and perfectly silent for all of eternity. But because the number of bubbles is truly infinite, absolutely every single physically possible configuration of reality must exist somewhere out there in the dark. There must be other bubbles where the conditions are perfectly tuned for life, where other ancient stars burn, and where other conscious, curious minds look up at their own alien night skies, quietly wondering if they are alone in the vast void. The profound mysteries we have gently explored throughout this entire journey, the massive, mature galaxies discovered by the golden mirrors of the James Webb Space Telescope, existing too early in time, the invisible, immense gravitational currents of the dark flow silently pulling our galaxy clusters toward an unseen edge, and the haunting, symmetrical mathematics suggesting our cosmos might be nested inside a massive, parent black hole, all beautifully harmonize with this grand, multiversal architecture. They are the subtle, barely perceptible whispers from the outside. They are the gentle ripples on the surface of our pond, quietly revealing that our isolated, three-dimensional reality is deeply, inextricably connected to a much larger, unimaginably complex metastructure. We are not a solitary, lonely accident floating in a dead, empty void. We are a tiny, glowing thread intricately woven into an infinite, living tapestry of realities. To fully, deeply embrace the concept of the grand multiverse is the ultimate exercise in human humility. Every time our magnificent telescopes improved, every time our mathematics grew more precise, the cosmos gently but firmly pushed us further away from the center, revealing a reality that is consistently larger, stranger, and far more magnificent than our fragile egos could ever imagine. The multiverse is the final, ultimate displacement. It patiently tells us that even our entire, staggering universe, with its 100 trillion stars and its billions of years of deep history, is merely a microscopic, insignificant drop of water in an endless, eternal, falling cosmic rain. And yet, within this ultimate displacement, there is a profound, deeply comforting peace to be found. The true purpose of scientific exploration is not to conquer the universe, nor to arrogantly shrink it down to a size that our small minds can easily manage. It is a continuous, beautiful surrender to the infinite mystery. When we finally accept that we will never reach the absolute end of the map, that there will always be another hidden layer, another silent universe bubbling up in the infinite dark, we are completely freed from the exhausting burden of needing to know absolutely everything. We are allowed to rest comfortably in the deep, quiet shadow of the unknown, fully recognizing that the mystery itself is far more beautiful and far more vital than any final answer could ever be. As you lie there, safely surrounded by the quiet shadows of your room, feeling the gentle, rhythmic rise and fall of your breathing, allow the weight of the infinite to simply lift off your weary shoulders. You only need to be exactly what you already are, a curious, conscious, deeply feeling expression of the universe, quietly experiencing itself in this incredibly brief, beautiful moment in time. The ancient atoms in your body will eventually peacefully return to the stars. The great bubbles of the multiverse will continue to eternally rise and fall, expanding and dissolving in a magnificent, silent ballet that has no true beginning and absolutely no true end. And that is perfectly, beautifully okay. Our gentle journey through the dark has brought us to the very edge of human comprehension. But it is not the end of our shared exploration. For now, as the night deepens and the world around you falls into a peaceful, undisturbed slumber, let your mind completely relax. Let the gentle, invisible current of the cosmos carry you away into sleep. You are safe. You are a vital, beautiful part of an infinite, nested reality. Sleep peacefully, my fellow traveler, knowing that the ancient burning stars will silently, faithfully keep watch over you, exactly as they have done for billions of years, and exactly as they will do for billions more.